So we'll go ahead and get started here as people funnel in. We got a couple of get to know us slides, so they can get to know us at the end, and you guys get to know us first. To start off with, my name is Karinne Bessette. I'm a technologist with Veeam Software, and I play in a lot of clouds. Generally speaking, most of my time spent in the Microsoft 365 side, but I also dabble in the Azure, GCP, and AWS. So my approach to this is I can't know everything, but I still have to be in charge of everyone on my team to know what they're accessing, what they're doing, and make sure they're not spending too much, because then I'm the one that has to justify it to the rest of the company. And then Chris is here to join me for the more technical bits of nitty-gritty AWS side.
Chris Bowles, 20 years in all kinds of flavors of tech. Last 6 or so on a DevOps team, living and breathing AWS all day. AWS Kubernetes. Working on my Kubernetes cert someday. And trolling ran a little bit. She likes light mode, I like dark mode, so if the slides go back and forth, that's why.
You can't see dark mode when you're doing presentations. I used to be a fan until I got tons of negative surveys about it, but we'll move on from that. So if you didn't scan the QR code on the first slide, this one is here. We'll also have this QR code at the end slide. This is what it looks like when you click on it. You just find the presentation that we're doing today, or if you want to take a sneak peek at some of the other slides that I do in content, that's all there. You can also connect to communities. I do want to do one small plug. There is a Women in Microsoft 365 group that I help with. We do content every month, and then I actually run a book club, a learning club for both technical and soft skills for women out there. So you want to help promote that. I also may have some stickers in my bag if you come up after the session. So let's get started here, because what we're really talking about is FinOps. And I think it's this really funny word because this kind of came out of nowhere when I heard analysts start going in on it, and I'm like, okay, but what are we really talking about? And can you kind of ground this back into real terms? And really what we're talking about is cloud optimization. They just rebranded it, and then it became really fun. So what we do is kind of define a visibility about what is in the cloud, what we're doing, and we'll cover a little bit of how you kind of make sure you're not doing something wrong to start with. But unfortunately, a lot of us are here because we got the bill and we're like, oh no, something's gone terribly wrong. How do we come back from that? How do we have the visibility? Then we have to shift over to putting the accountability on the people in our organization, because it can't just be one person in charge of seeing this, knowing what's there, and then taking care of the remediation actions after that. So we'll start off with more of the visibility and the accountability side of the equation, and this is just getting into the admin side, which is called the console when we're talking about AWS, but in my org, it's going to be for Microsoft 365 Admin Center stuff. So I usually start off with, what is the portal telling me to look at? And you can see a difference between when you first get in versus Chris here has a second screenshot. So when you first get in there, it's telling you about the optimization hub already, telling you to create a budget and kind of get that visibility. But once you're there, you start getting things like the budget plan alerts, so you know when something's gone wrong. So the cost optimization hub is really cool. It's not just something that goes out there once and says, okay, these are all the things in your infrastructure, good luck, go. What it actually does, it actually takes at least 24 hours in your infrastructure to see how your data is processing, how data is moving between regions, and what processes are happening. Once it gathers all of that back, it starts to give you feedback, and then you start to get these nice, pretty charts, which, you know, it's kind of great for the IT side, but really good for management, because then you can show over time how these charts start to shift, how the cost spending is happening, and you can get even more advanced if you start to do things like tags. So if you tag your individual departments, you can say, yes, the entire AWS side is this much money, but finance over here just bought an application through the marketplace, which has shot up our costs so much that's why we've had this inflation, even though there technically may be different cost portfolios in the company. Another thing that I look at here is actually the anomaly detection. I actually take this as two different sides, because this could be sort of like a little Easter egg that something else could be going on in your organization. A big thing here is talking about how the percentage change from the Q service. In my organization, I run a lab and I work for a backup company. So all of a sudden, overnight, we can go from 0 bytes being egress from the organization to gigs and even terabytes of data, which will then kind of inflate these numbers. But if I wasn't in that position and all of a sudden I see all of this data being exfiltrated from my company, one, it costs a lot of money, and two, I might have a problem with data leakage somewhere along that line. The different types of budgets, I normally just go with the recommended cost budget. There are some bigger kind of integrations that they've done over time, but then you start to kind of get into the weeds and it gets really complicated really fast. And like I said at the beginning of this presentation, this is not the only cloud I live in every day, and learning the intricate parts of every single one across the way has become somewhat of a nightmare of my position and job when it's not my day job to do this, but I'm managing the other people on my team. So what do? We ask for help. And actually, they have a new thing out there now, which is going to be the FinOps side. I named my agent Finding Fin. I thought it was adorable. Seems anyone get it? Finding Fin? Finding Nemo? Maybe? No? That's it. So the really cool thing about this is still in preview, but it gives you some ideas on how you can get the data in your organization and then what you can do with it after that. Some cool things that already integrates into Jira and Slack. So if you have a ticket that needs to get generated, you can send that over that way. Or if you need to let a team know, hey, your cost is up 75% this quarter so far, and we've not finished yet, that might give them the visibility that they need. And now we talked about dark mode. This one was my screenshot, so I do use dark mode, I promise. But this is just asking to check my S3 cost every 24 hours, and it automatically creates a task to go out to my entire organization, see the utilization, present it to me, and then the change over time. And it was easy as that prompt, and then it has a little bit of validation set in right here saying, hey, this is what we think you should do. Do you want me to do it? And it's even really nice. Shall I go and do this for you? And I say yes. All of a sudden, I am now informed about the storage cost in my organization. So there's a different kind of thing that we can do whenever we've found out where the problem is and where it lies. And we're going to have a resource optimization. Maybe we need to have a bigger resource. Maybe we need to have a smaller resource. You're not using this all the time. Or we're talking about scaled infrastructure. Then we can have a cleanup process. There's a ton of rot data out there in your infrastructures. If you're not using like a tiered type of object storage, getting this to something cold, you're going to be paying tons of money for that over time. Then you can talk about reconfiguring. And Chris will go over some of the new features that are kind of out there to allow you to get better cost optimization, because we did a lot of this theory from on-prem to cloud where lift and shift was a big thing, but lift and shift end up costing more than most of our jobs. So what we've come back to do is, okay, we have the optimized integrations and services that we can now tap into. I'll pass it on over to Chris.
Hi. So some of the more practical dives, one of my big drums is clean up after yourself. And I'm a DevOps guy, so I'll dig at my devs. Clean up after your devs too. One of my favorites is infrastructure as code. Yeah, it's great and repeatable. It's great for security reasons. But the big one is when you're done with your skunkworks POC, you delete that whole stack. There's no losing track of a bucket or a role or anything else that goes with it. It all goes. A lot of services, Workspace and SageMaker, are ones that will continue to idle. Some of them do have config flags for automatically spinning them down after they've been idle for an hour or so. But if you're not careful, you can leave that thing running all night, all weekend, come back Monday to a really nasty bill. Lifecycle policies on lots of things in Amazon are great. If that's an S3 bucket, you can delete after a certain amount of time if you don't really need it. You can glacier it if it's cold storage. EBS snapshots now have an archive tier that's relatively new. That can save you some money if you need to keep it, but you don't really need it hot. ECR registry, if you're saving images, put in a life cycle to delete after so many versions or so many days. The big one, to points Rin touched on, read your bill, use Cost Explorer. This graph is a real world oopsie where our EBS snapshot policy, one of our junior guys incorrectly interpreted the tag conditions as a and condition when it's actually an or. So a wildcard snuck in there and we were snapshotting every EBS volume every night or hour or something, and that was not fun. And the drop off you see is, hey, why is this doing this? Let's delete all of those. Catch that mostly by reading your bill and wondering, why has it gone up? instead of just somebody in finance getting angry and coming to you like, why is your spend double what it was last year? Compute side, this is where I spend a lot of my time. Look at the different instance variants. A lot of people are afraid to play with some of the newer stuff. Not exactly new, but the AMD variants, which end in A, work exactly the same as the Intel variants, usually cheaper and faster. The Flex instances are relatively new. They're only available in Intel. You're sharing the box, kind of like the T-Series, but effectively you have priority. You're getting the box most of the time. It's good for things like a build box that maybe you need 100%, but then there's times when it goes completely idle. Amazon can steal your idle time with those, but you're paying less than the full instance. Migrate to Linux. I know this is not just a dig on Microsoft, but if you're running Windows instances, you're paying double. Once for the hardware, once for the license. So anything that you can move to Linux cuts your bill in half. If you're running in Java, if you're running in the modern variants of .NET, Ruby, anything with a runtime, this should be relatively easy to do. Similarly, migrate to Graviton. This is Amazon's ARM64 chip. They've been out for several years now. I think they're on Gen 4 or 5 at this point. Same concept as the Apple Silicon chips, the M-series chips that are showing up in your laptops. They're a lot more efficient to run. I think the number Amazon advertises is 40% cost to performance benefit. It's quite a lot. And again, in most scenarios, if your app is abstracted from the hardware, it won't know or care. There are some caveats depending on the type of your app. If you're doing very CPU intensive, might not be the right answer. But at least in my world, we're very network intensive. It's mostly web apps where you're waiting on stuff to come over the wire anyway. So the CPU efficiency is very much worth it. This is your boilerplate you see a lot in the docs. Use your saving plans, reserved instances, consolidated billing. Build a billing org. Start with a master account, ideally empty, don't put anything else in it. Just use it to be the parent of all of your other accounts. Pay your bill through there, so you pay the bill once. You get one consolidated invoice then. You can still drill down and see what's on each account. But this also allows you to leverage, when you buy your savings plans and reserved instances, you can buy them at the parent level across accounts. Saves a ton of headache. And then also, once you've got that org, you can build it as a billing org. You can also then pivot that same org into a management org and do security policies and such across the whole org. Know your workload. This one, touching on the runtimes up here again, most of your runtime-based languages are garbage collected, and garbage collectors are typically lazy. This leads to fun things like memory-based autoscalers don't play nicely with lazy garbage collectors. Because it's lazy, it will look like you're consuming more RAM than you really, strictly you are, but you don't necessarily need to be. And that will cause you to auto-scale to more instances than you actually do need, which of course is real money. A big hitter, if you use any of the AWS services with large quantities of bandwidth, is a VPC endpoint. This basically takes the various Amazon services and drops a network card from their service onto your VPC as if it's on your LAN. The S3 one's a little bit different. It comes in a gateway version and an interface version. But the rest of them are just interfaces that get dropped on elastic IPs. And then your traffic routes through that. Some orgs do this for security reasons. You don't have to allow egress to the internet now to get to these services. But the other thing it does is for billing reasons, it's not crossing, if you've got a transit gateway, NAT gateway, it's not crossing any of that. It's never egressing to the internet. It's cheaper and it's generally faster because this stays closer to on-prem. These ones I highlighted because S3, obviously you can be pushing some large files. ECR, large container images. CloudWatch can be large quantities of logging. I probably run upwards of a couple gigs a day in logging. Some of these other ones are also beneficial, but you're not going to drive as much bandwidth through there. Hopefully you're not nearly sending as much email as you are writing container images. Maybe you are, it depends on your workload. In our shop, I didn't highlight them because they're kind of specific, but we use a lot of SNS and SQS. That's not going to be the truth for everybody though. EKS is where I live and breathe most of the day. Karpenter is a relatively new, fun tool. It's an open source tool created in Amazon. It sits in the same place that the cluster autoscaler used to live. So this is deciding how many nodes should live in your cluster. It does not change the way kubescheduler works. That's a common misconception. But what it does do is when you drop a pod on your cluster, you'll actually see some warnings. Unschedulable. That's a good thing. Kubescheduler will see that and create a node for you. It's a little hard to see, but over here is a node pool config. You basically describe what instances are allowed to be in your pool, and then turn Karpenter loose and say, find me one that makes sense. Notice in here, I'm not specifying, I guess I'm specifying a minimum number of CPU cores. I don't want to mess with anything that's fewer than 4 cores for my purpose. But mostly you let it go. Use a very broad pool because, jumping down here, this is another variant of the experiment with interesting instances. The like M5A-N or D or DN, they're instances that have faster network cards, more disk, both. Most people are afraid of those and don't mess with those because they don't know what they do, and they normally cost extra for on-demand. But for Spot, it's about supply and demand, so those instances can often be cheaper. In the case of Karpenter, you just say, find me the cheapest node. It's like showing up at a baseball game and seeing what tickets you can get. You can save a lot of money and make Spot very easy. If you notice in here in my capacity type, I have Spot listed. Say I'm willing to take a Spot node or an on-demand node. Spot will almost always be cheaper than on-demand, but that's a fallback just in case Amazon runs out of Spot instances for some reason, which does happen sometimes. But yeah, you turn this loose and then you look at your cluster and you'll have all kinds of exotic flavors. I just noticed M9G, but brand new 2-week-old Graviton chips showed up in my environment. Karpenter just does its magic. For a real-world example, we went from, so this is my EKS cluster in dev, grouped by node pool. So the blue over here is no node pool at all. This is pre-implementation of Karpenter. They, of course, had node groups, but not node pools. Same concept, but the terminology changes when you switch to Karpenter. So this here is when we started turning on Karpenter, and you can see we started getting node pools. This was, I don't know, probably the last week of the month, so that's why that chart is not terribly full. This is a whole full month of it, and you can see, so the pink is what we call branch nodes. Those are all running on Spot for our dev branches. The green was our default main branches, and the purple was our self-hosted GitHub runners. As we moved down by August, we got confidence to say, hey, what if we just move all of this to Spot? It's all dev, even the main branches. So you see a pretty big drop here. Much bigger drop when we went to all Spot. And then because this screenshot actually existed totally unrelated to this talk, I also have a call out for when we implemented webhook-based scaling on our autoscaler. And so you can see that purple bar got significantly smaller. Also shut it off on the weekends and overnight. Scaled up on demand if a dev happened to be working at 2 a.m. on a Saturday. That's their problem. But they'll get a node. Otherwise, I'm not going to keep it sitting around waiting for them just in case. That saved a ton. Yep. This is now same kind of idea, but org-wide. This is all of our EKS spend across the org. So you can see here, this is where we got that dev implementation. It dropped down. We got the rest of the environments as we went, and it tapered nicely down and maintained a nice steady run rate there. Doesn't look like a ton on the graph, but that's $2,000 a month in savings just in the EKS cluster. That adds up real quick. And then my last one, this is kind of a bonus. Also inside AWS, the team that built Karpenter actually built this to show off what they were doing. It's called EKS Node Viewer. This connects to your cluster, and each of these lines is a node in your cluster. These are not utilization in workload sense. These are in allocations in your Kubernetes reserved resources, requested resources. So it shows you the whole thing you got, the price per node, whether or not it's Spot, how many pods are on it, what kind of loads on it, cluster-wide, and some spend quota. Of course, this, I look at that and freak out and go, oh God, $4,000 a month. This is scaled up in the middle of the day. If I look at this again overnight, my number goes way down because the devs go to bed and I idle down. So it averages out quickly, but that's a nice little resource to look at. And it's live. It works like Top, so it's constantly refreshing. You can watch, especially if you do a cluster rollout, you can watch nodes disappear and reappear and workloads shift. Just a great way to visualize what's going on in your cluster, where your spend is, and find, this is probably a brand new node that hasn't taken any load yet, but if it had been around a while, I'd be concerned as to why do I have this empty node? Why is this node kind of 2/3 full instead of completely full? Lots of good diagnostic. Kind of boilerplate, again, the slides if you want them, the sessionized feedback, and probably in the posted version, but a list of resources on the next slide.